here we go now. Okay, so let's start with our first slide. Okay, so who are we? And by we, I mean Thoughtworks. So we are like a leading global technology consultancy, and we try to integrate strategy, design, and software engineering to enable enterprises and technology disruptors across the globe to thrive as modern digital business. Basically, what I like about our company is the culture that we have and how we have projects and we strive for positive social change. And yeah, as I mentioned, the culture is like really good. I love it because it's really different from anywhere I've been previously. Okay, so yeah, who are we? We've already done that. Okay, so let's start with defining the principles of OO. Let me see why I cannot see you now. Okay, here. Okay, so basically we have like these three principles of object-oriented programming. We have encapsulation, which is hiding the specific design of something that can change or that is like really susceptible to change, and protecting other pieces of our code of getting the knowledge or of being affected of that change. Then we have the polymorphism, which is the ability of objects belonging to different types to respond to method calls of methods of the same name, each one according to an appropriate type specific behavior. So meaning that, sorry, that was my dog. So meaning that, yeah, objects can behave differently. And the third one is inheritance, which is the mechanism of basing an object or class upon another object or class, retaining similar implementation. So we have these three principles. How do you think, or which one do you think that it's more important in object-oriented? Or if you have to rank them from 1 to 3, how would you rank them? Which one would you say that it's like the most important and which one is the least important? Feel free to speak.
I would say that the most is, I don't know, all three are good, but maybe encapsulation.
Okay.
Yeah, I agree.
I think too, because the oriented object is the concept is the more mix is the encapsulation. I think, yes.
Okay, so first we might have encapsulation, and then, or the least one, the least important one.
Polymorphism, I think, is the least one.
Okay.
Because inherence is also important in object-oriented thing.
Okay. Any different opinions?
I put in the second place irancy because is more the concept is more, I think that is more important for me, obviously.
Okay. Do you all agree? Do you have any other thoughts, ideas of this ranking?
I agree with the encapsulation is the first one, but I'm not sure about inheritance be the second one. Because you know, sometimes it's something that you need to properly. If you do a lot of inheritance, it can be the code can start being a bit messy.
Mm-hmm.
So I don't know. I know it's supposed to depend on the solution that we are looking for.
Okay.
Well, in my opinion, for me, all are the same. The three are important. I cannot choose one or other, honestly, for me.
Yeah, I was going to say the same, yeah. Yeah, it's like none of them are like, they all depend of the other one, yeah. So for me, yeah, it's like all three are important?
Yeah, I think the same. It may depend on the requirement, maybe.
Okay, so let's see what happens. Okay, so we've got on the first place encapsulation, on second place polymorphism, and on the third place inheritance. I think that basically I can remember who mentioned, but inheritance might not be as good as it seems. Always me during my university time, it was like inheritance. It's like super important. But as you keep practicing and you gain more experience, you kind of start to realize that maybe somebody has sold us inheritance as like the thing that would solve all of our lives. But as we are going to see later, sometimes it's better to not do inheritance and do other strategies. Okay, so main principles of object-oriented programming. First, encapsulate what varies, which is what we've mentioned before. Take what the piece of code or whatever you think that it's going to vary and encapsulate it, so it won't affect the other parts of your code. And yeah, basically by doing this, we would avoid some consequences, some bad consequences of that change happening in the rest of our code. Yeah. The second one is favor composition over inheritance. This is what I was talking previously. Usually, so inheritance is kind of is a whatever relationship, like this is a whatever, and composition is has a, so whatever has a whatever. So usually composition is better than inheritance because it gives you a lot more flexibility. So it allows you, for example, to encapsulate a family of algorithms or whatever. But what also is like a really good point for composition is that it allows you to change behavior at runtime. And we will see more of this, of the composition with a design pattern that we're gonna see later on. Third, program to interfaces, not implementations. Yeah, so it's like a really good practice to do an interface, and that the other objects or classes or whatever that are going to interact with some objects, that they interact directly with the interface, because it kind of also has to do, it's related with the first principle, right? We encapsulate what varies. So we have an interface, and we agree that, and the composition also, we have some interface and there are some objects that might implement that interface. But in that subclasses or objects that implement that interface is the code that it's going to vary. So we have in our interface what we think that it's not going to vary. So it's better to program to interfaces rather than to implementations. And fourth, yeah, only talk to your friends. So when we're programming and we're designing a system, we have to be careful of the number of classes that interact between them and how do they interact between them. Because by doing this, it prevents us from creating some designs that might have like a lot of class coupled together. So maybe one change in one class could affect the other classes. Okay, so far so good. Any question, doubt, suggestions? Nope. Okay. So let's move to how objects interact. So first we have delegation which is like a one-way relationship. A knows about, so we have like these three layers, and A knows about B. B does not know about A, and elements of A can cross the line towards B, and elements of B can cross the line towards C, but not backwards. So for example, one example of this is, as it's shown here, something that we have to persist in a database. So yeah, we can, I mean, elements and information travel through layers and layers to the database, but they do not have to know where they have come from. They just have to know that they're going to go forward and forward and forward. Okay, yeah, collaboration, two-way relationships. Both objects know of each other and work together. So an example of this might be when we have a class and a student. So the object class knows that it has students, and the object students knows what class they have. So both objects interact and they know of each other, of the existence of each other. And well, what we've mentioned, inheritance, which is an is-a relationship, which is, yeah, basing an object or class upon another object or class retaining similar implementation. We've got here like the example of a tree. We have like the tree superclass, and then the subclasses, which is the coniferous tree and the deciduous tree, but they both share the species, height, age, growth, blah, blah, but they have like unique methods from themselves, the coniferous and the deciduous tree. Any questions so far? Nope, nope. Okay. Was anybody want to ask something? I thought I heard someone like starting to talk. Nope. Okay. Okay, so now we have mutability versus immutability. What do you think that this means? Or what is mutability or what is immutability? Feel free to speak.
Mutability is when objects or elements change.
Mm-hmm.
And immutability is when they cannot change. I mean.
Okay. Okay, cool. Yep. So mutable objects are objects that can be changed after they are created. They might not be thread safe. We have a program that works with several threads. Mutable objects can be kind of a headache because they can be modified in the different threads at different times. So it might be a bit tricky to work with them. And immutable objects are objects that cannot be changed. They are safer because they are thread safe. And for example, in Java, we declare them with the final. It's a reserved word. That means that we are making that attribute or whatever immutable. Okay, cool. Okay. So far, so good?
Yes.
Yes.
Okay. Design patterns. Have any of you worked with design patterns or have heard of design patterns previously?
Yes, some of them.
Okay, okay,
Yes.
which ones?
Yes.
Singleton, builder, command, I don't know.
Decorator.
Yeah.
Cool,
Template method.
cool,
Strategy.
cool, cool. Okay, okay. So we're gonna see some of them here. We're not gonna see them all because there are like too many. But we're gonna see, I think that it's like 4 or 5 of them. But if you want to take a look at any other pattern, you feel free to ask and we might take a look at it. Okay, so basically, what is a design pattern? A design pattern is a solution to commonly occurring problems. So yeah, it's just something that when you've been through the same stuff like a lot of time, you might get to a solution that kind of solves your issues for that particular thing. And it provides a common language when talking about a solution. And we will be using the following structure. It's just for explaining purposes. So we have the title, the problem, the solution, the trade-off, and an example. Cool. Okay, so types of pattern. Does anybody know what types of patterns there are?
Yes. The creation object.
Structural and behavioral.
Okay. Okay, so sorry, we have creational, structural, and
Behavioral.
Cool, yeah. Okay, so we have those three. Creational, the ones that are involved in the instantiation of objects and provide a way to decouple a client from the objects it needs to instantiate. Behaviorals, the ones that solve how classes and objects interact between themselves. And structural, it's basically that let you compose classes or objects into larger structures. So we're going to see the following design patterns, and we're going to talk about them, and we're going to decide whether if they are creational, behavioral, or structural. So first, strategy pattern. I think that somebody mentioned before that they work with the strategy pattern. Nope, nope.
Well, I said view controller, but I don't.
You mean like model view controller?
Yeah.
Yeah. So it's not exactly the same.
Sorry.
No worries. Okay. So anyone mentioned the strategy pattern that they've been working with the strategy pattern before?
I think that somebody said facade.
Facade. Okay, that's another one. Nope. Don't worry because I might have imagined. So don't worry. Okay, so the first one we're going to look is at the strategy pattern. So problem, for example, an object needs to have different ways of doing the same task. You want to be able to choose between different algorithms of behavior for an object. And you have like several if-else statements determining the behavior. So just with this sentence, what kind of pattern do you think it's going to be? So remember we have creational, behavioral, and structural.
Behavioral.
Behavioral.
Behavioral?
Yeah.
Cool.
Mm-hmm.
Okay, yeah, cool. It's behavioral. So basically with what we do with the strategy pattern, it's we encapsulate a family of algorithms and make them interchangeable. Making interchangeable so that the program at runtime, it can choose what algorithm to use at any time. So the pattern or the solution would be to decouple the behavior from the object and isolate them, which is what we've mentioned about encapsulation and all the stuff. Make the original object delegate to these classes. And then, well, they are implemented as anonymous inner classes. That's how you can implement it. And basically, they are declared as constraints in the original object. Okay. So the trade-offs we can have for this pattern, for the strategy pattern, is that it enables one algorithm to be swapped for the other one at runtime, as we mentioned. Design might get a little bit complex because you are adding subclasses and you're encapsulating a lot of stuff, and you have got a lot of different classes. And yeah, often static or constant implementations forces you to passing containing objects to work on. So I was going to say something, but now I've totally forgotten. Okay, yeah, sure. So what does this kind of reminds you to? The thing of encapsulating something, and so that a superclass, let's say, can select which family of algorithms to execute at runtime. What concept that we've already seen kind of reminds you of?
Polymorphism, maybe, kind of.
Polymorphism. Any other
Mutability,
answer?
maybe?
Okay, any other?
Encapsulation.
Encapsulation, okay. Any other? Nope, nope. Okay, so for me, it kind of sounds like composition, right? Because we encapsulate something and we allow the superclass or another class to select at runtime, sorry, what family of algorithms they're going to use. So a strategy pattern kind of uses composition. So we're going to see now this slide that it's like the basic schema. So we have the strategy here, and we have concrete or specific strategies that use this common strategy, but the outside class only works or only talks with this strategy, with the main strategy. So let me, oh, someone wrote in the chat. Okay. Okay, so let me share the other thing here. Where is it? File. Are you all familiar with Java? Or how familiar are you with Java?
Yes.
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 Yeah.
Mm-hmm.
Yes.
Okay. Okay, okay, cool. So let me open my IntelliJ here. React, blah, 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 blah. Strategy. Okay, okay, okay. So, okay, I'm going to look at my other screen now. Okay, cool. So, let's say, how can I hide this? Hide floating controls. Okay. So we have our program strategy pattern. If you want to ask something, just unmute you because I'm looking at another screen right now and I cannot see the main Zoom window where you raise your hand or whatever. So feel free to speak up. Okay, so we have the strategy pattern here. You see my IntelliJ, right?
Yes.
Yes.
Okay, okay, cool. So the strategy pattern, and I've got, let me open this. And I've got here my billing strategy, which basically has my interface, which has this one method that is get price. So basically what I have here in my main method strategy pattern is like if I am running a bar, or yeah, a bar, for example, and I have like 2 different prices for my beverages. One which is like the normal strategy, which applies to the normal hours, and the happy hour strategy, which applies to the beverage that have been bought during that happy hour hours. So I have my normal strategy here, which is, let me open it here. Okay, so as you can see, normal strategy implements billing strategy, and basically it returns the price, because when we are not an happy hour, I want my beverages to be the price that they are usually. And I have my happy hour strategy that implements billing strategy. So what this does, it just that the beverages have the price. So I prepare the strategies here. I say I'm going to have two strategies, the normal one and the happy hour one. So let's say that the first customer comes in. Customer bill, it's a new class here, and it's just got like the drinks and the strategy that we're going to apply to that specific customer. So first customer comes in, and we're going to apply the normal strategy to it. So first order of this first customer, because it's a normal hour, it's not happy hour, we just add the price, it one item of 100, whatever. Okay, so our first customer is still in the bar when the happy hour starts. So what we do is to this first customer, we set the new strategy to the happy hour. So set strategy, it's a method of the customer. And what it does is basically changes this attribute, this billing strategy for this specific customer. So basically, we now are setting the strategy to happy hour. And we're just saying that instead of having now one item of 100, he's got two items of 100, okay? So now a new customer arrives, and it arrives during the happy hours. So we can directly in the constructor of our customer say that it has the happy hour strategy set by default. And the second customer just orders one item of 80. And now they want to leave. So we're going to say the first customer, sorry, wants to leave. So we're gonna print, and what this print basically does is like prints its receipt, like with the total amount of money. And then we have the second customer, it's still in the bar, but unfortunately happy hour has ended. So we apply now the normal strategy to the second customer, and he buys all these items, and then he also wants to leave, okay? So as you can see here at runtime, we are setting the strategy to choose of the prices of the beverages between normal strategy, which is just the price that is set, or happy hour strategy, which is half of the price, okay? So let's run this and see what happens.
I'm super fan of the build bar that you have.
Yeah, the Nyan Cat.
The Nyan Cat, yes.
yeah, it's a new plugin for IntelliJ to make your life a little bit funnier.
Sure.
Okay, so we have the first one, the first customer. The bill is of 200, and the second customer it's of 550. Okay, because we had for the first customer one of 100, which is like the normal price, but then we came into the happy hour, and the happy hour was half of the price. So it returned the half of 200, which is 100, and 100 and 100 is 200. Okay, so we've got like the result here. Is it clear for you all? Do you want us to go through it on the back and see how it changes the strategy? If you need to, please don't be afraid of asking it. We have like 3 more hours, so do not worry, please.
It's okay.
It's okay.
Yep. Is it okay for you all? I don't want any one of you to leave with any doubts, please.
It's
Yep.
okay.
No, it's okay.
Okay, cool. So let's move now to Whoop, to IntelliJ. Okay, so to the next slide, which is basically the previous diagram, but applied to our example. So we had like the customer bill, which had the list of drinks and the billing strategy, and the method set strategy, add, which is like the when he orders something, and print, which prints the total amount that he has to pay. And then it had the billing strategy, and both the normal strategy and the happy hour strategy implemented from the billing strategy. Cool. So next one, Singleton pattern. I think that some of you mentioned that they've worked with the Singleton pattern, right?
Yes.
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 Okay, so Singleton pattern. Problem, we need to ensure that a class has only one instance. So what kind of pattern do you think it is? Creational, behavioral, or structural?
Creational.
Creational.
Creational, all creational?
Yes.
Yes.
Yeah.
Yep.
Yes.
Okay, you're all wrong. No, it's a lie, it's creational. Okay, so yeah, basically we ensure that there's only one instance of a class and that anyone can access to that instance. So pattern solution, letting a class manage a single instance of itself and preventing other classes to create instance of itself. So trade-off, the Singleton pattern can mask bad design. For instance, when the components of the program know too much about each other. So because you have this, and no one else is going to create a new instance of me, but maybe that's just hiding something much dirtier and smellier. And yeah, this pattern requires a special treatment in a multi-thread environment. For example, when we go into Zara or whatever, and we want to shop online, but we would like, or the ideal thing would be that one user has only one shopping basket for themselves. Okay, so basically easy, sorry, easy schema. We've got the client and the singleton. Okay, so let me change again to my IntelliJ stuff. File, open recent, not here. Okay, not here, open then. Desktop, oh no, she's not on the desktop. File, open. Thoughtworks, the woman app, samples, OP, Singleton. Cool. Look how nice the IntelliJ is going. It's going crazy. Okay, so let's start from the beginning. Client shopping. So we have our, our client class, which has name, username, password, and their shopping cart. The client shopping, which is like the main, oh Jesus. Sorry, I have too many tabs open and now my computer is going crazy. But anyway, we have this shop now. And we have the main, which is it's like a really simple program. And we are creating a singleton, the shopping cart, and we are passing it as an argument to the constructor of the client. So easy peasy. We just, when we do here, the singleton shopping cart, we go here. We say that the singleton class has got an attribute which is unique instance. So on the constructor, it does nothing. And when we do get instance, we say, if there is not a unique instance already created, we will create a new one. So return new Singleton shopping cart. Else, if there is already a unique instance created, we would just return this instance. Okay? So basically, shoop, shoop, shoop. Okay, this would be our schema. Okay, so let's see what happens with the Singleton pattern. We have these pieces of our code, and now we are going to use it in a multi-thread application. So what do you think it's going to happen if we run first the thread? We will start with public static whatever, right?
Yes.
Okay. So maybe top. Here, for example, this thread, it's starting to the get instance method. So what is the value of unique instance at this moment?
Null or whatever it is equivalent in Java.
Yeah, null. Okay. So now we have, imagine the second thread, it's going to start. So now it's starting to the get instance method. What will the value of unique instance be?
Null2.
Null again.
Cool. Okay. So meanwhile, the first thread is keeping on with its stuff, and it says, if unique instance equals null, which by the way, unique instance is still null, but thread 2, it's moving along. So if unique instance equals null, unique instance is still null. So both threads are going to go in the if statement, whether if unique instance is null. So first thread would create a new Singleton shopping cart because unique instance was null. So instance 1, for example, but thread 2 is going to do the same because at that point, unique instance was still null. So we're gonna have 2 instances of a Singleton shopping cart, which leave us with no longer a Singleton object because we have two instances of the same object. Okay, so let me swap to my IntelliJ again. Singleton. File, open. Common app, examples, Singleton. Okay, so what we're going to see now is a thread-safe implementation of the Singleton pattern. So hide floating meeting controls. Okay, so we still have the same classes. We have our client shopping, our Singleton shopping cart, and our client. So client shopping, shopping cart, get instance. So there are like 2 methods of doing this. One is the one that it's commented, that you still create the unique instance like this. You just say that Singleton shopping cart has a unique instance attribute. And then in the ifs that we saw before, you make the get instance method, you make it synchronized. So synchronized is a reserved word of Java to deal with threads, with thread safe. I'm not like really an expert on multi-threading and concurrency in Java, but synchronize is a reserved word to deal with this. Or the other thing you can do is, instead of just saying that Singleton shopping cart has an attribute unique instance, in the exact moment when you say that Singleton shopping cart is a unique instance, you directly create it. So there's no way that that two threads are gonna create different instances, because you already, when you instantiate firstly this item, this class, sorry, you already say, okay, new Singleton unique instance is directly the new Singleton. And when you do the get instance, you directly return the unique instance attribute. So this would be like a thread safe implementation of the Singleton. Okay, any doubts? Questions, suggestions, doubts? Nope, nope.
No.
Okay, so do you mind if we take like a 3 minutes break for my back? Because, oh, I didn't mention, or maybe some of you weren't here. So I have some problems in my back, and I have to stand up for like a couple of minutes every hour or so. So we're gonna have like this kind of tiny little break. So you want to grab a coffee or go to the bathroom. And we're also going to have a 20-25 minutes break later on. So if it's okay for you, we can do this little break now of 2, 3, 4 minutes.
Okay.
Perfect.
Yeah, that's fine.
No, no problem.
Cool. Okay, thanks. See you in a bit.
Okay.
See you.
See ya. Resume the recording, share a screen, share my desktop, this one, blah, blah. Okay. Let me see, where is my other thing here? Okay, so next pattern, the observer pattern. Anyone has worked with the observer pattern before?
Yes.
Yes? Okay, cool. So let's go with the problem. One object's behavior is closely tied to the state of another object, but we don't want to break encapsulation and poll the other object's state frequently. What kind of pattern do you think that this might be? Behavioral, creational, or structural?
Behavioral?
Behavioral, yeah.
Okay, everyone behavioral?
Yes.
Yep. Okay, yep. So it's a behavioral pattern. So definition, it defines a one-to-many dependency between objects, so that when one object changes a state, all of its dependents are notified and update automatically. This is like a really common thing that you get. I remember when I first started and I was just doing polling all the time, and at some point my machine just stopped working and it died. So this is just to avoid the constant polling, the constant polling. And basically what we do is a listener interface is created, and listeners register to the object that they want to be notified when the state changes. And then when that object changes its state, it notifies all the subscribers or listeners that, hey, my state has changed. So trade-offs, it can be more complex to trade through an event system. Don't pull out interfaces if they're not needed. Potential for circular or cascading notifications in a heavily event-based system. Personally, I've never encountered this problem, but I know some people who have, so it's a tricky one. And yeah, and show subject is in a consistent state before calling notification. This kind also happens that maybe the state, it's a bit like not in the right state where it should. So maybe we have to do something else to ensure that it's in a consistent state. Okay, so example, event framework in a string or other UIs. Let us know if the mouse, keyboard, etc. events occur. So instead of being like they're polling, it's okay, when you have done something, you let me know. It's like, don't be too pushing. Just I let you know when something happens. I let you know. Okay, so we have the schema of the observer pattern, which is basically a publisher, which has a list of observers. It also has got the methods of add observer, remove observer, and notify observers when something has happened. And we have the observer interface and the concrete observer A and the concrete observer B. So let me again put my IntelliJ here. File, open, observer pattern. Okie dokie. Okay, so in here, for example, we've got high floating meeting controls. Okay, easy one. We have a chef and an oven. So imagine that me as a chef, I want to know, or you don't have to be a chef. I mean, you're going to make your dinner and you want to know when the dinner is done, but you have other things to do. You are not just taking care of the oven. You're also taking care of the pan, and you also have to cut some things. So you cannot be constantly going to the oven to look at when it has ended. So what we do is the oven, it has now an array list of chefs. Okay, so oven, we create the oven, whoops, yep, with the new array list. Here, we have the chef. Chef, when we create the chef, we say, okay, so the chef is going to take a look at this oven. So the oven, and in the oven, we say register this chef as an observer for this oven. So let's go to the register chef as observer. What does the register chef as observer do? It adds this particular chef to the array list of chefs that are taking a look at this oven. There can also be a remove chef as observer, but we have not implemented it here. Okay, so what I want as a chef is that when the cooking has finished, you oven let me know. So cooking is finished for whatever reason it is. And what is done is notify to the subscribed chefs that the cooking has finished. So for each chef of the chef's array list, to chef, my cooking has finished. So now the chef say, my cooking has finished. Okay, so this dish is ready to serve. So instead of the chef being the one that go constantly to the oven to see, it's just the oven that says, okay, my cooking has finished. So now I'm going to notify to all the list of my chefs that are subscribed that I have finished. Okay. So this would be the schema of our observer pattern here. Okay, so we have the oven, we have an array list of chefs, and we have the chef. We have in the constructor of the chef, we have the oven that we want to take a look at. And in the oven, we have register chef as observer, remove chef as observer, notify subscribed chefs, and whatever it also needs to have. Okay, so when cooking has finished, it calls notify subscribed chefs and let the chef know that the cooking has finished. Okay, any doubts, questions? Nope.
No.
Okay, cool.
Well, one question, could you move the logic of registering to the client? In a sense, I register myself instead of having it in the observer, having it in the subscriber somehow.
So you mean, let me put again strategy.
So instead of
so you say instead of, sorry?
So instead of registering from the observer, that the like the subscriber could register itself. So could you move the logic there? Would it be okay? So instead of yeah. So you're the chef and you want to register to the observer. So that would imply that you need You register actually.
Yeah. So you have, as a chef, you have the oven you want to register to take a look at.
So you do the logic from here. Yeah. Sorry, I hadn't seen it. Yeah. Okay.
Sure, no worries. So in the constructor, you just say, okay, so I want to take a look at this oven. So the chef has this oven, and I say, okay, now that I have this oven, I want to register myself as an observer to this oven. And basically what the oven just do is add it to its array list. Yeah, for chefs.
Yeah, okay.
Okay. Any other questions, doubts, whatever? Feel free to ask. No? Okay. So let me minimize this again and go to the composite pattern. Composite pattern, has anyone worked with the composite pattern?
No.
Nope. Anyone? Nope. Okay, so basically the problem. Individual objects and collections of those objects have
Paula, are you sharing the IntelliJ?
Sorry. I thought I minimized it. Okay, now. Individual objects and collections of those objects have very similar functionality, and thus there is code duplication across the classes. Having to distinguish between the objects and its collection makes the code complex. This pattern allows you to treat individual objects and collections of those objects uniformly. What kind of pattern do you think this would be? Creational, structural, or behavioral?
It is a structural.
Yes.
Structural?
Structural.
I agree.
Yeah, cool. So basically it's a structural. What it's like if you create a tree of a structured tree, and you have from each branch, let's say, you have a leaf, which is like the item itself, or you have another structure which has more branches that lead to either more structures or more leaves. So let's you compose object into 3 structures. May start out with just an interface, cannot. But the main thing about this is that the clients do not know whether if they are dealing with a collection or the item itself, being a collection of items. So they do not know whether if they're dealing with just the leaf of the tree or a collection that it's going to go deeper and create some more structures and some more leaves. Trade-offs, it might be difficult to provide a common interface because you have like the structure itself and the composite and the leaves then. Like this example, for example, you have 2 types of objects, products and boxes. Imagine we are Amazon. So a box can contain several products as well as a number of smaller boxes. And these little boxes can also hold some products or even smaller boxes and so on. Okay, so you create like a tree falling down with branches and leaves and more boxes and more products. So the schema would be something like this. The client, we have the component, which has whatever it has to do. And then at some point it might have a leaf. And at some point it might have a composite, which itself can lead to more composites or more leaves. Okay, did I explain myself in a, did you understand it?
Yes.
Not really.
I think I need an example.
Okay, so let me see here in my IntelliJ again. File. Open. Where is my composite? Okay, open here.
The composite could be like a branch, and
yep,
the other one is the leaf. Yeah.
Let me see if here we can see it better, and if no, I will just draw it. No worries. composite. Let me just get, where's my thing to draw? Here. Whoops. Okay, so this is like our main, our entry point. And we are Amazon, imagine. So we can have, if we are packaging something as Amazon or as our friend or whatever, we have like a main box, and that main box can contain a pencil, or maybe it contains a smaller box, and inside that smaller box, we can have items, or we can have smaller boxes, even smaller boxes that contain items. It's like a Russian doll kind of thing. Okay, so we have the product, which is an abstract class, and we can add, remove, get the name, get the description, and print. Okay, and we have the product, let's see, box, and from the product, the item, box item. Okay, so we have box that extends from products, and we have the constructor with the name and the description. We can add more things to that box. We can remove things. We can get the name, get the description, and print, which just said that this is a box. And in case this box has more boxes inside, with this, with the iterator in the products, we say, okay, while there are more things, while products, which is, remember this array list of things that might be inside this box. While products, while iterator has next, while there are more products in this box, go to the product iterator next, and so on. So you start to dive deep, 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 deep into the tree until you get to the last item. So as you see, box extends from product. So the product that we can have here can be a box itself, or maybe it can be a box item, because it also extends for products. Okay. So let's say we have many deliveries. In this one, we just have a single box. So package containing only one box item. Cool. Now we have a composite package. So this is a box, and it's a package containing boxes that contains box item. So we have the composite box that is a box, and it's a box that contains a box item. And we have the composite box item, which is a box item, which is like the leaf itself, the last point of the tree. Okay, so all packages, add. So we are going to, all these, we are going to ship them. So we are going to add the single box, which was the single box item, which was just one box item. Now we're going to add the composite package. The composite package was a box. And now to this composite package, we're going to add a composite box, which was this one. And to the composite box, we're going to add a composite box item. Is it clear, all these add?
Yeah.
Yeah?
Yes.
Okay. Okay, so let's gonna run it. Okay, so what we have got is all this. So let me paste it somewhere else where we can take a look at it without going crazy. Okay, so can you see my text thing now?
Yes.
Yes.
Okay, so first we have, this is a box, which is like the big one, like the big single delivery. And all packages. So this one has inside a box item, which was the single box item that we mentioned first. So that is it. For the first item, it's just the box item. For the first node, sorry, it's just the box item. Now we're moving to the other one that was the composite, I think it was called. Okay, so the main shipment has inside a box, which is the composite product. This box has inside another box, which is the composite box. And inside that box is a box item. And that's the last leaf of the tree. And then it goes up. It's recursive. It's kind of recursive thing. And then it goes up, 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 and it finishes. So what we've done is just basically we've covered all the nodes and leaves of the tree. Is it clear?
Yeah.
Because it's, yep.
Yeah.
Sure. Anyone has some questions, just say it, because this one is a bit tricky.
Could you go back to the code for a sec?
Yeah.
Just to compare again,
Sure.
to check that I understood.
Yup. Okay. Okay, here. So we have, let me hide this, floating meeting controls. So we have product, which is like kind of our interface. And as a client, I don't know whether if I'm dealing with a box or a box item. I don't know. I just know that they both extend from product. So from the main entry point, we have the single box, which is just a box item. It's just like a pencil thrown over there in the box. And then we have the composite package, which is a box.
Yes.
And
it's okay. It's okay. Yeah.
Yep.
And I was just checking the structure from the main function to check that I constructed the tree correctly. I mean, it's okay. Yeah, I think I got it. I think.
Sherry?
So, yeah.
I mean, if you still have any doubt, feel free to ask.
No, it was just to cross-check that the structure was
cool.
Okay, thank you.
No worries. Anyone else has any question? Nope. Composite pattern so far so good. Okay. So, whoop. Okay. Just doing weird things. No. Here. Okay. So this is the composite pattern. This is the schema that we were like the general schema. Okay. And now, why can't I change the slides? Oh, shit. Sorry. Okay. Yeah, basically this is what we've been looking at. It's just the component, and then it can be a leaf or it can be another box itself. So the leaf would be our box item. We can have our box item, or we can have a box that can have a box item, etc. Cool. Okay, so factory. How many has worked or knows about the factory pattern?
Yeah, I use it.
Okay.
I use it.
Yeah,
yes, me too.
Okay. So, what would you describe your factory pattern? How would you describe it?
Like a class that allows you to create many objects, different objects, following certain factors, maybe, but yeah, to create something.
Okay, so basically what I was asking this is because we usually say factory pattern, factory pattern when
there's two of them, isn't it?
Yeah.
And there's the
that's
abstract and the method or something like that.
Yeah. So we have there's misunderstanding because we usually use factory pattern for these three things. The simple factory, which is actually not a design pattern, but it's something that we might have to use like frequently. The factory method and the abstract factory. Okay, so we're going to take a look at the simple factory and the factory method. So simple factory describes a class. Remember, simple factory is not a design pattern. Sorry. Describes a class that has one creation method with a large conditional that, based on method parameters, chooses which product class to instance and then returns. So if we have like, if whatever, then new whatever. If whatever is A, then return new class A. If whatever is B, then return new class B. So that would be simple factory. Then we have the factory method. That factory method, it's actually a design pattern. It's a creational design pattern that provides an interface for creating objects, but allows subclasses to alter the type of an object that will be created. So it allows the subclasses to choose what kind of object it's going to be created. And then we have the abstract factory, that it's a creational design pattern that allows producing families of related or dependent objects without specifying their concrete class. So, yeah, simple factory. Simple factory isn't actually a design pattern and is usually represented by a single method in a single class. So let's go to IntelliJ and let's open the factory one. Oh, okay, so let's go here. I'm going to close all. Okay, so burger customer, for example. Our main entry point, we have a burger factory. See, this is what we were talking about. If the type of the burger equals cheese, blah, 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 then we create a new cheeseburger. Else, if equals veggie, it creates a veggie burger because we have the burger abstract class, the veggie and the cheese, okay? And cheese, both cheese and veggie extends from burger. So what they do is, for example, the name and the ingredients. Cheeseburger, we want to add cheese, and veggie burger, we want to add veggie meat. So burger customer, okay? We create the factory, burger factory. Remember, it's the one that, in order to make the burger, sees the type of the burger, and based on the type, it creates a different burger. So we also have the burger store here. Okay. So we assign to this burger store in the construction the factory. Okay, we say this factory equal a factory. Burger. This store, imagine I only have one store because I'm like a startup of burgers and I do only have one store. So I want to make a burger, okay? And I said that the burger class, the burger type is simple factory burger. So when I go to make burger, it says, okay, make burger. It's going to return a burger, okay? So how do you return the burger? You do the factory, make burger, because if you remember, the burger factory is the one that had the make burger method with all the if whatever. Okay, so factory make burger, we pass as an argument the burger type. What? And this method is the one that decides what burger to create, either the cheeseburger or the veggie burger, and returns it. Okay, and then returns it whether if we've ordered a cheeseburger or a veggie burger. Okay, so far so good.
Yes.
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 Okay, so now let's move to the, sorry. Now, to the factory method. Okay, so problem, we need to create objects, but these objects are not always created the same way or with the same attributes. So what kind of design pattern do you think it might be? Creational, structural, or behavioral?
Creational.
Yep. Okay. Okay, so yeah, it's a creational one. So basically it defines an interface for creating an object, but lets the subclasses decide which class to instantiate. So we have here our diagram, and we have the product, the concrete product, the creator, and the concrete creator. So I think that this one is going to be seen much better in IntelliJ. So I'm going to close all this. So remember that we mentioned before that I was a startup and that I only had one store. But imagine that now I'm starting to become bigger and bigger, and I'm starting to become a bit like McDonald's, and I want to open 2 different burger stores. I want to have one store in New York and one store in California. But as you know, as McDonald's does also, in different countries or in different places, they might add different things to their hamburgers. So Veggie Burger might have some ingredients in the New York store that it does not have in the California store or whatever, for example. So, okay, we still have our burger store, which has the create burger, but as you can see here in the make burger, we do not have any longer that big if that says whether if the type of the hamburger is veggie, then create the veggie. If the type of the hamburger was cheese, then create it. That logic is not here anymore. We'll see where it is. Okay, so we have the burger store, and we have that the California burger store and the New York burger store extends from that burger store, okay? So we've let now the subclasses that are, in this case, the New York burger store and the California burger store, decide how they want to create their burgers. So instead of being the burger store with this huge if here, decide what hamburger it was going to create, now it's the subclasses. So we're going to create a burger. Now we only have cheeseburgers because we are too lazy and we only have cheeseburgers. So the New York store is going to create the burger. Let's see how the New York burger store is going to create the burger. Okay, so we have create burger. If the type of the burger is cheese, we're going to create a New York cheeseburger. Okay, so now we have the abstract class burger, and we have the name and the create burger that does whatever it has to do. And from this burger abstract class, both the California cheeseburger and the New York cheeseburger extend from it. Okay, so we have the name, New York cheeseburger, ingredients, we add cheese, and in the California cheeseburger, we add mozzarella cheese, for example. Okay, so we are in the New York store and we are creating the burger. So we go to the New York burger store, create burger. If the type of the burger is cheese, we are returning the New York cheeseburger that use normal cheese. So Ethan ordered out whatever. Now Ethan or Joel has moved to the California store. So let's see how the California store creates a burger. It's going to create a burger, California burger store. And if item equals cheese, but you see it's the same type of hamburger is cheese, it's going to return the California cheeseburger, which has mozzarella instead of regular cheese. So let's run this, and hopefully it would create 2 different types. Okay, so Ethan ordered the New York cheeseburger and Joel order the Cali cheeseburger. Okay, but it was the subclasses of the burger store, the ones that decided what kind of hamburger and the modification that was going to have. Okay. Any questions? No?
No.
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 No, no, no. Okay. Okay. So, those were the patterns that we were going to look at today. So now that we have all this information and we have like all this knowledge in our head, we have to be careful because overusing design patterns can lead to a more complex and an over-engineered code that is difficult to read. So it's like when you hear a new word and you learn a new word and you just keep hearing it everywhere. So it happens the same with design patterns. Once you've learned the patterns, you're like, oh, I see patterns everywhere now. It's like you're full of knowledge and you see patterns everywhere. So yeah, in other words, a great power comes with a great responsibility. So we have here like 5 principles on how and when to use design patterns. So first one, it's called KEYS. That stands for keep it simple, stupid. So basically our goal is simplicity, is to have a code as simple as possible. So do not overuse patterns. Also, design patterns are not magic bullets. I mean, they help you sometimes, but they're not always the solution to your problems. Maybe your problems is that your architecture is completely wrong or whatever, but don't try to use them to solve any other issues that you might have. So when to use a pattern? That is the million-dollar question. So just use it when you are like completely sure that it's going to solve the problem and there is no simpler solution. I mean, for example, in the factory method that we've seen, maybe you come across this problem and you say, oh, maybe I can use a factory method, blah, 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 and you start doing it, but maybe you didn't need the factory method. Maybe with the simple factory was good enough. Maybe you are just over-engineering and created more classes and adding more complexity to the code that you would need. Also, YAGNI stands for you ain't gonna need it. So basically this is that do not work on advance. You have to avoid implementing things that you don't know whether if you're gonna need it. And you have to resist the urge to introduce a pattern somewhere unless you know and you have the practical need for it. So like a good example for this is when you are coding and you say, oh yeah, I'm going to imagine that you are doing a calculator. And you are doing I don't know, you are just starting with the sums, with the additions. And you create a method. Oh yeah, I'm going to create a method for subtractions. Wait, but that's not in our requirements. You ain't gonna need it now. This is a YAGNI. The subtraction method would be a YAGNI because you ain't gonna need it right now. You are just thinking that you might be going to need that in the future, but you do not know whether if you're going to need it for sure. And maybe it's going to add more complexity to the code that you really need. And also, when you are in your code and you want to refactor or you have to refactor, that is a good moment to take a look and see whether if what you're needing is a pattern. So it's a good practice to, when you have some, I don't know whether if in your jobs you have, but if you have some technical depth task and you have to refactor, just take a look and see whether if maybe a pattern might solve not all, but some of your problems. Okay. Any questions, doubts? No, yes? Okay, so let's do a little bit of hands-on. So going back in time, we kind of saw the following patterns. It was a strategy, singleton, observer, composite, and factory. I think that were all the ones. So let's try to do some briefly exercises. Okay, so imagine, for example, I have no one has used it before, but I have an app that shows me the route from point A to point B by car. Let's say that we're going to call that maps, for example. Okay, so I have that app and it just shows the route by car. But as people start using it, I realized that I wanted to add some features. For example, how to go from the same point A to point B, walking or by train. So what I was going to tell you the pattern. What design pattern do you think that it might be good to use at that point?
Strategy, wouldn't it?
Strategy.
Strategy or strategy? Anyone else thinks another one of a strategy? Do not be shy. No? Or a strategy? Cool. Okay, yeah, so basically it's a strategy. Why? Because it allows us on runtime to decide whether if we want to calculate that route by car, walking, or by train. Okay, so next one. I've got a logistic apps. Let's call it Amazon, for example, just totally made up. And it handles the transportation of our boxes, the ones that we were talking about in the composite pattern, by truck. But as time goes by, this app becomes popular. And suddenly we have some plane companies, some companies that also use planes that want to use my app to transport their things, their boxes or their items by plane. But what is the problem? That because our app was done only for trucks, all the main code is in our truck class. So what pattern do you think that we might want to use in here now that we also want to be able to handle transports by plane?
Factory method.
Factory method. Anyone else? Agree? You all agree in factory? Anyone disagree? Disagree is good also? No? Okay, yeah. So basically it's factory. What we might want to do is just extract the common things to an interface that's, I don't know, transportation or whatever. And afterwards we would have the subclasses of the truck and of the plane or the ship or the boat or the train or whatever. And we can add them. But we have that main interface now that all those subclasses can extend, and depending on whether we want to use it with a truck or with a ship or with a plane or whatever, we can use it. Okay, cool. Anyone doesn't see really why we should use the factory method? Or is it more or less clear? Clear? Okay.
Yeah, yes.
Okay, cool. So now, for example, I am super interested in, I don't know, in when a rock band that I like, it's going to release the new album. So, but I only know one place here in Madrid that sells their CDs, their albums. So I start going to the shop to ask when is it going to be to release the album of this new, the new album of this group. But you know now sorry.
No. sorry, I was.
Okay, no worries.
Yeah, I was going to say observer, but I wanted to let you finish.
Yeah,
sorry.
that's right. Yeah, so basically I just want to stay at home and let this shop let me know when the album has been released so I can go and buy it. Cool. Okay. So now we're going to do like another type of exercise, really little one. So we have some sentences and we have some blanks and we have to fill in the blanks, right? So we have the first sentence, which is blank, what varies? What would blank be?
Encapsulate.
Cool. Yeah, encapsulate. So we always have to encapsulate what varies so that it won't affect or it would affect in the minimal way possible the rest of our code. Okay. So program to blank, not an implementation, not to an implementation.
To an interface.
Cool. Program to interfaces, not to an implementation. Also, because what we mentioned before about encapsulation, if we program to interfaces, it's less possible that it modifies. Okay. Favor blank over inheritance.
Composition.
Composition. Cool. Okay. So based on this thing, what we mentioned before on the first slide, I think it was that inheritance wasn't that important in object-oriented. Do you now see why it's not that important in object-oriented, or have I not convinced you yet? Yeah, I have convinced you?
Yeah.
Yes.
Cool.
Yes.
Okay. So next one, in the factory method, who decides which class to instantiate is the blank.
The derived class.
In the factory method, who decides which class to instantiate?
I think it is a subclass.
The subclasses of the function.
Cool. Any other answers, possible answers? Or we do all agree in subclass? We agree. Okay, yeah, it's the subclass. As we've seen in the factory method, we delegate that responsibility to the subclass. Is the subclass the one that decides how to create and what object to create, and if that object needs any modifications or whatever. Okay, so in the Singleton pattern, multiple what can cause problems? Multiple blank can cause problems.
Threads.
Cool. Okay. Yep. So we've seen if we do not use the thread safe implementation of the singleton, we might end up with maybe the shopping cart is not that critical, but imagine if you want to I don't know, to do a login in some web page to claim your $11 million prize. Imagine you do it twice. You get your prize with $22 million. Obviously, that's good for us, but maybe not so good for the people that that did the rifa. I don't know how to say in English. Okay, so another kind of exercise. Let's see. Okay, what pattern encapsulates in? I'm gonna read it because I don't want to mess it up and say you the wrong thing. What pattern encapsulates interchangeable behaviors and uses delegation to decide which one to use?
Strategy.
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 All strategy. Any other thoughts rather than strategy? No? Yep. So yeah, it was a strategy. So yeah, basically that's widgets encapsulate Sorry, the dog. It just encapsulates the behavior, so at runtime we can decide which behavior to use. Okay. What pattern? Okay, subclasses decide how to implement steps in, no, sorry. Yeah, subclasses decide which concrete classes to create.
Composite method.
In the
What,
factory
sorry?
method.
Factory method.
Factory method.
Factory method.
Yep. Yep, cool. So yeah, well, as we've seen with the burger, is the subclasses of the burger store, the New York burger and the Cali burger. Sorry, the New York store and the Cali store, the ones with that decide which burger to create. Okay, cool. So next one, what patterns allows objects to be notified when state changes?
Observer.
Observer, nice. What pattern ensures one and only one object is created?
Singleton.
Cool. And the last one, I think, client treats collection of objects and individual objects uniformly.
Composite pattern.
Cool. Composite. Yep. Okay. So any questions, or was anyone not sure what pattern to say with these definitions? No? Okay. Okay, cool. So let's go to the solid principles, which is the last part of the workshop. Does anyone knows what solid stands for? Or what are the solid principles?
A leader, yes.
Okay. Okay, would any one of you would like to do a little introduction? If you would like, if not, it's okay. Remember, this is a safe space and you can say that you don't want to. But you can also give it a try. Donate. Okay, so basically, solid principles, here they are, is a mnemonic. I think it's said, it's in English also. It's there. It's a mnemonic acronym for 5 design principles that are intended to make software designs more understandable, flexible, and maintainable. Sometimes it's tricky to remember also all of them and how you should implement it, but let's take a look at them. Okay, so of solid, the S stands for single responsibility principle. The O stands for open closed principle. The L stands for least cost substitution principle. The I stands for interface segregation principle. And the D stands for dependency inversion principle. Okay, has anyone heard of these principles before?
Yes.
Yeah.
Cool. Someone said no?
Yes.
I haven't there.
Okay, so please, if you have any question, just say it out loud, because it might not be as easy for you. So don't worry, just speak up. Sorry. Sorry, my dog was just whining. Okay, so we have the first one, which is the single responsibility principle, which states that every module, class, or function in a computer program should have responsibility over one single part of that program's functionality, and it should encapsulate that part, which also links to the fact that a class or module should have one and only one reason to be changed. So imagine we have a module that compiles and prints the monthly reports or whatever. So how many reasons do you think that this module has to change? A module that compiles and prints the report. Does it only have one reason to change, or does it has more than one reason to change?
Okay.
Only one reason.
Two, wouldn't it?
Two
And
reasons.
it compiles and it prints. So it does two things.
Okay, yep. So imagine that the content of the report change, or how we want to compile it change, but the printing is still the same. So we have one reason for change, that it's how to compile or the data to use. That's one reason. Or imagine that the compiling is still the same, but we want to print it in another format or whatever. So we can change how it prints it, but still compiles the same way. So we have two reasons for it to change. One, the compiling thing, and one, how it's printed or the way it's printed. Okay? Any questions, comments, doubts? No?
I cannot see your screen. I will try to connect again. Yes.
Sorry. Do you all see my screen? Let me stop sharing and reshare again, just in case. Share screen.
Maybe problem with my connection. I don't know.
Can you see my screen now?
Yeah.
Yes.
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 Okay, so don't worry, Jasmine, because it was basically just the definition, and it was an image representing the single responsibility principle. So don't worry. Anyway, if you still don't see it or you have any question, just let me know. Okay, so next one. Whoops, sorry. The open-close principle. So it states that every module, class, or function in a computer program should be open for extension, but closed for modification. So imagine the factory, the simple factory that we had. We could still add some new burgers, the cheeseburger, the veggie burger, the New York burger, the whatever. So that would be open for extension. But if we want to delete one of the types, or if we want to do another modification, that would go against the open-close principle. Okay, so this is what it's also really good to encapsulate what varies and program to interfaces, so you can avoid this. Okay, any question?
Can you give another example, or because I'm not?
Yeah, sure. So imagine, yeah, the burger one, for example. I'm just going to use the previous example. We have if you remember, we had an if that says if type was cheese, then create the new cheeseburger. If type was veggie, then create the new veggie burger. So what this open-close principle states is that it's okay for a class to be open for extension. Like, for example, now I want to add more types of burgers. If type is, I don't know, with egg, then create with egg burger. If type is with guacamole, create with guacamole burger. That it's okay. That it's a class open for extension. But a class should not be open for modification. If I want to delete one of these burgers, that would be a modification. Sorry. Okay, did I explain myself well?
Yeah.
Cool. Sorry if I go, because it's just that my dog is whining and messing all over the place. I don't know what she's trying to do, to be honest. Okay. So the next principle, Liskop substitution principle. Objects of a superclass shall be replaceable with objects of its subclasses without breaking the application. Okay, so basically what this says is that when we override the method of the subclass. I mean, when we override the method of the superclass in the subclass, it needs to accept the same input parameter values as the superclass. Okay, so we can substitute. I mean, it's like an imaginative substitution. You don't really have to substitute it if you don't want to. But if you do the exercise of trying to substitute this superclass with this subclass, it should not break the application. Okay. Any question? Or do you not quite see it?
It's clear.
It's clear?
Yep.
Okay. Cool. The next one, interface segregation principle. So basically, no client should be forced to depend on methods it does not use. Many client-specific interfaces are better than one general-purpose interface. So basically, it's much better to have a lot of small different interfaces so that each client use the interfaces that it needs to, than to have one big interfaces with all the methods that all the possible methods that all the clients might need. Okay, so because by doing this, we keep our systems decoupled. Okay, so each interface implements or has what the client needs, and we keep it decoupled. So it's easier also to refactor. And also we ensure that the clients only use the methods that they can use. Imagine, for example, that we have a login system. We do not want, this is a very like that example, but we do not want all the users to have access to the same methods. So we can have one interface for the admins, an interface for the common users, an interface for the database admin users, okay? So it's better to have a lot of different tiny interfaces than a big one with all the possible methods. Okay?
Yes.
Yeah. Cool. And the last one, dependency inversion principle. Basically, depend upon abstractions, do not depend upon concrete classes. This is what we have been taught also, that it's basically programmed to an interface, not to an implementation. This schema here, this drawing, it's using the pizza store and some pizzas. All the leaves here are pizzas, but imagine that instead of pizzas are being burgers. So this is what we had in the beginning, right? We had the burger store and we had all the burger types. But what dependency inversion principle is saying is we should have our burger store, and that burger store program to an interface, which would be our burger, and then all the burgers should also be programmed to that interface. Okay, like the factory method we did. Okay.
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 Yeah.
Questions, doubts? Okay. So far so good. This was all the workshop, as I mentioned previously, because it was the first iteration. Maybe it was going to be a bit shorter because we are still trying to manage all the time that we needed. So do you have any question, any doubt, want to ask about another pattern or whatever? This is your opportunity. Feel free, please. No?
Yeah, I have one.
Go.
So for me, the solid principles is like more or less the same that with the pattern. So I read about it like lots of times and all that stuff. But so when you guys, you know by heart, and then you are implementing the code and everything comes to your mind, oh, I cannot do that because that's breaking that solid principle, or is coming when you're refactoring. Because for me, some things are very clear that you know that you don't have to do them, but all of other other ones are coming when you are refactoring, saying, oh, yeah, I did that and I shouldn't, things like that. So I would like to hear like how you work with the solid principles.
Yeah, so for example, imagine in the, I don't know, the interface segregation principle. So maybe I'm doing a program and by the first iteration I do it, it's okay to have one interface. But as it grows, I might start to smell that maybe I have to put it in smaller interfaces so that each client is going to access the interface that it needs to. It's not recommendable to start like doing like, oh yeah, but I'm going to do separate interfaces because in the future I'm gonna because that's a Yagni. That's a you ain't gonna need it thing because you do not know, sorry. Because you do not know whether if you're actually going to need that so many interfaces. So you should just start with your first interface, for example. And as time goes by and you start to code and requirements come, you start to see that maybe you are going to need another interface. Maybe it's a good idea to split that big interface into smaller ones. So I would not recommend to start overthinking and say, okay, so to begin with, I'm going to do different. Also, because we work with Agile and it's easier because requirements come in and they go and we go step by step. But I would not recommend to start like going, okay, I'm going to do 7 interfaces for the customer with privileges, for the customer with not privileges, because maybe there are not going to be at the end customer with privileges or customer without privileges, because maybe the project shuts down and you leave there that code that it's useless and might add complexity, because if on the future someone takes up that code, it might go, why is this here? I mean, am I missing something? Am I missing some part of code? Because I don't see that this is used at all. Okay.
Yeah, okay.
Cool. Have I solved your doubt?
Yeah, it's what I thought, but I wanted to check with you guys because, you know, sometimes there is someone that is coming with the better, clever idea with all the interfaces at the beginning. And they were thinking, why do you know that? We don't know yet. Like the feeling that overcomplicating things when you start to implementing something.
Yeah. So I would not recommend that because you have the 2 things that we mentioned. Let me see, where is that slide? Hold on a second.
The KISS principle.
Yeah, I was just going to, because I don't know if it's here. No, I don't know where's that slide. Remember that we have like how, it's here. My bad. Here. Remember that we have the keys, the keep it simple, stupid. So if you're not gonna, by the moment, our goal is to do the code as simple as possible. So if we're not gonna need those interfaces, and at the moment it's okay to do maybe just one if, stick with that. And also because you don't know if you are going to need it in the future. Maybe you're going into the Yagni. You are trying to implement some things that you might not gonna need in the future. So this is all to keep the simple, to keep the code as simple as possible, always, and as understandable as possible. So yeah, I wouldn't like kind of agree with people that come with like all the structure in their head, like we're going to do 3 interfaces and we're going to do blah, 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 because designs evolve. So it's just better to go step by step, baby steps, one thing at a time, because at the end, maybe the design evolves in a totally different way as how you have thought.
Yeah, totally agree. Yeah.
Cool. Any other questions?
Paola?
Yep.
Can you return to the third solid principle? I don't. It's not totally clear for me.
The list of one.
I think that. Yes. Yeah,
okay. So this is more not something. I mean, basically, is you have to program your superclasses and your subclasses in a way that if. Sorry. You were going to say something.
The connection is.
Can you hear me?
Now, yes. I think that my connection is okay. Sorry.
Okay. No worries. Okay, so basically, you have to program your superclasses and your subclasses in a way that if theoretically I delete my superclass and I change it for a subclass, nothing breaks. So the way to achieve this is when I have a superclass and I have a subclass, the overridden method of the subclass needs to accept the same parameters of the superclass. Okay, and also with the return, the same thing applies to what the method should return. It should return the same thing. So if I theoretically remove that superclass and put the subclass instead, nothing breaks.
Okay.
Cool. Any other questions? Doubts? No?
I have a general question.
Yep.
It's not specific. I mean, how tight are these patterns related to the object-oriented programming languages? Because I haven't been programming in Java since a long time, and it's kind of difficult for me to identify those same patterns sometimes in another type of languages. And yeah, so that's my question.
So I've been programming without design patterns like a long time. And because as I told you previously, they didn't teach me this in the university. So I have no knowledge of this at all. And it's true that what you end up is kind of a messy kind of code, which at first might not seem so, but if that code grows bigger and it has to go through a lot of iterations and change of hands a lot of ways, it's just it has a lot of complexity, and sometimes it gets like really hard to follow. So design patterns is basically just a way of a common language, let's say, to mention a solution to our issues. It's basically just, it's not something like too complex. It's just a way of giving a solution, a name to a common problem that we might have during our developer life. So I think that, to be honest, I haven't worked that much in functional programming or outside object-oriented, and I don't know whether if all the design patterns can be applied to any other kind of languages. I would say that they can, but I cannot tell you with the total certainty because I do not have that many experience outside object-oriented programming. I don't know if that was your question or if I misunderstood it.
Yeah, sometimes I feel like I don't have a way to map a situation in another type of languages, for example, Node.js with these patterns.
Mm-hmm. Yeah.
And yeah, these patterns are to solve some problems, but sometimes in other languages you can solve these problems with a different type of design or regarding these languages. So that sometimes you want to check on the object-oriented in your own language, and You don't know where to put it, or how to solve it, or how to map this. And every time you get these patterns, we use Java, and that's great. But sometimes it gets you. But if you don't use Java, it makes you wonder what is this situation should be. And
maybe there are, as I've said, maybe there are some patterns that apply more to all the languages. For example, there's an adapter pattern. We haven't mentioned it, and maybe the adapter pattern is just basically if I have two components and I want to create something in the middle, let's say an interface in the middle, so that the information from the first component can be absorbed by the middle component that I've created, the adapter, transformed and moved to the second component in a way that the second component understands it. Okay, so it's kind of something like they're in the middle. Maybe this can also apply to Node.js, or I mean, it's something that you might create an extra component to manage that workflow of data between two different components that, let's say, expect different language quoting, meaning that they have different, I don't know, structure or whatever. So there are some patterns that might not apply too much outside object-oriented, but definitely, sorry, there are some ones that I would say that apply just to general programming.
Definitely. Also, there are some architectural patterns that somehow lead these design patterns that you are going to use.
Yeah.
In the model view controller, you have this specific way of doing things. Yeah.
Sometimes also as you mentioned, the architecture you choose leads you to apply or one pattern or another, or to ring a bell in your head of, oh, I'm going to use this pattern. Yeah, totally agree.
Yeah. Okay, thank you.
Sure, no worries. Any other question, doubt, whatever?
No.
No?
Not from my side.
Nothing? Okay, so anyhow, if you have any question, any doubt, if you remember anything, if you want more information about patterns, if you want to ask about a specific pattern that you've read, or if you want to ask whatever in the most general sense of whatever, you have my email here. Well, thank you very much again for coming to this workshop. And again, if you want to ask anything or whatever, you just have here my email.